Welcome to Lecture 1 of CS218 Data Structures and Algorithms. This course is intended for the fall semester of 2020. The target class is Second Year Computer Systems Engineering 2019, Kennedy University of Engineering and Technology. A little about myself. My name is Uruj Anuddin. I am an assistant professor in the Department of Computer and Information Systems Engineering, Kennedy University of Engineering and Technology. My office is in the research lab, which is on the first floor of the CIS Labs building. My office extension is 2350. And if you want to correspond with me, I would like that you email me at urujn@neduet.edu.pk. So first, we will talk about the course contents, the structure, and the evaluation methods that I will use. This is the course plan of DSA. The topics are Introduction and Motivation, Analysis of Algorithms, Asymptotic Analysis, Arrays and Lists, Stacks and Recursion, Queues, Linked Lists, Trees, Graphs, Sorting and Searching. So the total number of lectures or the total number of videos that you will get are 30. I am going to use 4 books for this course. Brans D. Nikkei's Data Structures and Algorithms Using Python, Mark Allenby's Data Structures and Algorithm Analysis in C++, 4th edition, Larry Nyhoff, EDT's Data Structures and Problem Solving with C++, 2nd edition, and Seymour Lipschutz, Data Structures in C. These are the books that I will be using, and from time to time I will be telling you the particular book which I am using for a certain topic. You are aware that the university is using outcome-based education, so we will be using the same system of education in DSA as well. Before we move to DSA, I would like to discuss the CIS framework regarding OBE. The full framework is available on the link that you see here, https://cis.neduet.edu.pk/OBE system. But I will be discussing with you those parts of the framework that are relevant to this course. Bloom's taxonomy is a way of classifying the things that we learn from any educational experience. And Bloom's taxonomy lays down 3 domains of learning. These 3 domains are cognition, psychomotor, and affective. What I'm trying to say is that after a learning experience, sometimes we grow in our knowledge. This is cognition. Sometimes after a learning experience, we grow in our skills, the skills or the things that we can do with our hands. In Urdu, there is a special word for it, hunar. So if a learning experience gives me a motor skill, then the kind of learning that I have done is psychomotor learning. Sometimes after a learning experience, I find that my attitude has turned better, or I have grown in my feeling, or I have grown in my emotion. This is affective learning. So either I can grow in knowledge, or I can grow in motor skill, or I can grow in emotional capacity after a learning experience. These are the 3 main domains of learning laid down by Bloom's taxonomy. Each of these three learning domains have labels in them. Look at the cognitive learning domain. This refers to the learner's ability to process information in a meaningful way. And there are levels from knowledge to comprehension to application to analysis to synthesis to evaluation. The lowest level is knowledge and the highest level is evaluation. These are the levels of cognition. In the affective domain, we talk about learners' attitudes and feelings that are a result of the learning process. The lowest level is receiving, then we go to responding, then valuing, then organizing, then characterizing. In the psychomotor domain, we look at the learner's ability to use motor skills to learn. We start with perception, then set, then guided response, then mechanism, then complex overt response, then adaptation, and then origination. I am not going to talk about the affective and the psychomotor skills because my course is only mapped to the cognitive domain. So in the slides to follow, I will focus on the cognitive domain. Now let me talk about levels of the cognitive domain. The first level is knowledge, recognizing or remembering without necessarily understanding. So I tell you a definition and then I say what is XYZ and you give me the same definition back. This is the first level, knowledge. Comprehension, the second level, demonstrating understanding of facts and ideas by organizing or comparing. So I tell you a few things and then I ask you which of those things is better and you give me one name. This is the second level. This is comprehension. The third level is application, solving problems in new situations by applying acquired knowledge. I show you how a formula is derived and then I write down a word problem and I ask you to apply that formula. This is application. The fourth layer or the fourth level is analysis, examining and breaking information into component parts, looking at the inner details of something. This is the fourth level. The fifth level is synthesis, building a structure or pattern from diverse elements. Now you know so much about that particular thing that you can make a smaller model of your own. And the last level is evaluation, presenting and defending opinions by making judgments about information. Evaluation comes after synthesis because this is the place where you have synthesized more than one solutions to the problem and now you are actually calibrating those solutions and telling other people which one of them is better. Program learning outcomes. There are 12 things that we will calibrate for every student and based on those 12 attributes we will come to a conclusion whether this student has passed this program or not. So these 12 PLOs are PLO1 engineering knowledge, PLO2 problem analysis, PLO3 design or development of solutions, PLO4 investigation, PLO5 modern tool usage, PLO6 the engineer and society, PLO7 environment and sustainability, PLO8 ethics, PLO9 individual and teamwork, PLO10 communication, PLO11 project management, and PLO 12 lifelong learning. Every course is not mapped to all of the PLOs. Each course is mapped to some of the PLOs based on the contents of the course. Now let us look at the course learning outcomes for data structures and algorithms. There are 3 CLOs for this course. CLO 1 is elaborate fundamental data structures. This is a cognitive CLO of level 2. And what was level 2? Yes, it was comprehension. This CLO maps to PLO 1, engineering knowledge. How am I going to assess this CLO? I'll be setting you quizzes, assignments, and the midterm and final term will also be used as assessment tools. CLO 2 is to analyze time and space complexity of algorithms. This is a cognitive CLO of level 4. Level 4 was analysis. It maps to PLO 2 of problem analysis. And again the same assessment tools are used here as were in CLO 1. CLO 3 is practice with algorithms for widely used computing operations. This CLO governs not only the theory portion but also the practical portion of DSA. This is a cognitive CLO of level 3. This means it relates to application. And this maps to PLO 3, design and development of solutions. Now, since we will be working with this CLO in the labs, there are rubrics in the practical lab to evaluate the CLO. I will be setting you down a complex engineering activity and there will be rubrics for that complex engineering activity. Obviously, this last CLO will also be judged in the midterm and final exams. I will assign you 40 sessional marks, 20 of which will come from the midterm exam. And the complex engineering activity will involve algorithm design and coding. Students will be asked to submit a report containing the code. So this is all about the course learning outcomes of DSA. Before we move to the contents of the course, one last question. Why do we need this course? We have learned how to code in Python and we have learned the basics of object-oriented programming. DSA helps us in 2 ways. We need to acquire the skills to write fast and memory-efficient algorithms. And we need to create optimized solutions to problems. And for both these things, DSA is going to help us immensely. So let's start data structures and algorithms. Introduction to DSA is our first chapter and we are going to use book 1, chapter 1 for this topic. Data types. In programming languages, we are provided with a few different ways in which we can collect and characterize data. These ways are called data types. In the popular programming language C, we have the int or the int data type for storing integers, float for numbers with fractional values, and char for alphabetical and special symbols. Each data type takes up fixed space in memory. An int data item takes up 2 bytes of memory. A float takes up 4 bytes and a char takes up a single byte. The int, float and char data types are simple data types because they cannot be decomposed into smaller parts. Complex data types are constructed of multiple components consisting of simple types or other complex types. In Python, we see many complex data types like list and dictionary. Can you think of more? Algorithms. An algorithm is a sequence of clear and precise step-by-step instructions for solving a problem in a finite amount of time. In easier words, an algorithm is a sequence of steps that halts somewhere. Abstraction. An abstraction is a mechanism for separating the properties of an object and restricting the focus to those relevant in the current context. The user of the abstraction does not have to understand all of the details in order to utilize the object, but only those relevant to the current task or problem. Two common types of abstractions encountered in computer science are procedural or functional abstraction and data abstraction. Procedural abstraction is the use of a function or method knowing what it does but ignoring how it's accomplished. Consider the mathematical square root function which you have probably used at some point. You know the function will compute the square root of a given number. But do you know how the square root is computed? Does it matter if you know how it is computed? Or is simply knowing how to correctly use the function sufficient? This is an example of procedural abstraction. Data abstraction is the separation of the properties of a data type, its values and operations, from the implementation of that data type. You have used strings in Python many times, but do you know how they are implemented? That is, do you know how the data is structured internally in the memory or how the various operations are implemented? Most probably you do not, but still you have been using the string data type in Python. Abstract data type. An abstract data type or ADT is a programmer-defined data type that specifies a set of data values and a collection of well-defined operations that can be performed on those values. Abstract data types are defined independent of their implementation, allowing us to focus on the use of the new data type instead of how it is implemented. This separation is typically enforced by requiring interaction with the abstract data type through an interface or defined set of operations. This is known as information hiding. Using information hiding, we can work with an abstraction and focus on what functionality the ADT provides instead of how that functionality is implemented. ADT is a collection of data and operations that work on that data. A good example of ADT is the list in Python. We can initialize the list, insert item in the list, remove item from the list, read next item from the list, without worrying about where and how the list is stored in memory or what is the actual code for all these functions. Operations on ADTs. ADTs can be viewed like black boxes. The set of operations defined on an ADT can be grouped into four categories. Constructors create and initialize new instances of the ADT. Accessors return data contained in an instance without modifying it, the get methods. Mutators modify the contents of an ADT instance, the set methods. Iterators process individual data components sequentially. Advantages of ADTs. We can focus on solving the problem at hand instead of getting bogged down in the implementation details. When we are storing data in the list, we do not worry about where the elements are stored in the memory. We never think about if the elements are stored contiguously in the memory or if they are scattered. We can reduce logical errors that can occur from accidental misuse of storage structures and data types by preventing direct access to the implementation. The only way to modify data items associated with an ADT is by using its modifier functions. So unless we call the modifier functions, we can be sure that the data is intact and unharmed by other function calls. The implementation of the abstract data type can be changed without having to modify the program code that uses the ADT. There are many times when we discover the initial implementation of an ADT is not the most efficient, or we need the data organized in a different way. By requiring access via the interface, we can easily swap out the black box with a new implementation with no impact on code segments that use the ADT. It is easier to manage and divide larger programs into smaller modules, allowing different members of a team to work on the separate modules. Large programming projects are commonly developed by teams of programmers in which the workload is divided among the members. By working with ADTs and agreeing on their definition, the team can better ensure the individual modules will work together when all the pieces are combined. Types of ADTs. Abstract data types can be simple or complex. A simple ADT is composed of a single or several individually named data fields, such as those used to represent a date or a rational number. The complex ADTs are composed of a collection of data values, such as the Python list or dictionary. Complex abstract data types are implemented using a particular data structure. So the next question is, what is a data structure? A data structure is a container for data. It helps to organize data. It helps to retrieve data. Let us look at the idea and importance of a container. You can put all your clothes in a giant sack and keep that sack in a corner of your bedroom. Every morning when you need to go out, you take some clean clothes from the sack and put them on. Another alternative is to store your clothes in a wardrobe. What would you like, the sack or the wardrobe? Do you think it would be difficult to find clothes in the sack? Do you think it would take you less time to retrieve from the wardrobe? What does this mean? Putting clothes in the sack takes less time than in the wardrobe because there is no organization in the sack. But retrieving your favorite green shirt from the sack is more difficult than it is from the wardrobe because of the organization in the form of shelves inside the wardrobe. Also, if you want to keep your formal wear together and your day-to-day apparel in another place, this is easily done in the wardrobe, but it is impossible in the sack. This brings us to a realization. The clothes are important because we have chosen them with love and bought them with money, but the wardrobe is important too. Bringing it back to our topic, we assign importance to not just the data that we want to store, but the container in which we want to store it. No matter what sort of container you use to keep your data, there are only 6 things that you can do with that data. So now we look at operations on data structures. The first is insertion, adding data to the data structure at a specified position. The second is deletion, deleting data from the data structure at a specified position. Third is traversal, moving through the whole data structure, visiting each data item exactly once. Fourth is searching, finding the position of a specified data item in the data structure. Sorting, or bringing order to the data items in the data structure. And the last is merging, joining two sorted data structures to create a single sorted data structure. A good container is one that optimizes these operations. So let us now look at each one of these operations in detail. Let's first talk about insertion. We must never add data to a data structure that is already full and does not contain any empty space. This is important in insertion. Adding to a full data structure results in an error known as the overflow. So if anybody says that an overflow has occurred, you should understand that somebody has tried to write more data to a data structure that is already full. Overflow leads to loss of data as an old data item gets written over by a new data item, and data loss is something that we do not tolerate. Deletion. Okay, think about this. When you need a fresh pair of clothes and you retrieve them from your wardrobe, this can be seen as deleting this set of clothes from your wardrobe. This brings us to two realizations. Deletion of data from the data structure is actually the retrieval of data, and deletion of data is done when the data item is required. We must never retrieve data from a data structure that is empty and does not contain any valid data. Deleting from an empty data structure gives us garbage values, which can never be useful. Data structures may be of two kinds, linear and non-linear. If during traversal at any position in a data structure there is only one direction to move to, it is a linear data structure. An example is the linked list, which you can see here. In a linked list, each node contains two elements. One is a data item and the other is a pointer to the next node in the list. Try traversing through the list. We start at the node pointer and move to the node containing 15. This node points to the one containing 30. Standing on one node, I have a pointer to move to only one node, which is the next node. You can see that traversal in a linked list will always be in a fixed direction. That is, we go from 15 to 30 to 6 to 7 to 4. So the linked list is a linear data structure. In nonlinear data structures, there exist one or more points at which we have more than one directions to continue traversal. Consider this example. This data structure is called a graph. Suppose I stand at the node containing 5 so that I can only move to the node containing 11. But now that I stand at 11, I can either move to the node containing 2 or the node containing 9 or the node containing 10. So traversal will depend on which node I choose to move next. The graph is a non-linear data structure. Notice that the traversal will change when I change the starting node. Let me share another example with you. This is a tree. You may say it is a graph, and you are right to say so. All trees are graphs. A tree is a graph in which nodes exhibit a parent-child relationship, also known as a hierarchy. Suppose that we start the traversal of this graph from the node containing 2. We can either move to the node containing 7 or to the node containing 5. Assume that we move to 7. Now we can either move to the node containing 2 or the node containing 6. So we conclude that a tree is non-linear too. The next operation is searching. Searching is implemented by traversing the data structure. Remember, traversal was moving through the data structure, visiting every record exactly once. A search is successful when the data item we are looking for is present in the data structure. We return the location of this item to the calling program, and we stop traversal when the data item is found. A search is unsuccessful when the item we are looking for is not in the data structure. We return none to the calling program. Sorting. Sorting is arranging items in an order. Following are some common orders: chronological, alphabetical, numeric. Chronological ordering means arranging data items according to the time stamp attached to them. Suppose I am asked to list down the qualifications I have earned so far. So I list an MS degree, then a BE degree, then an HSC, then an SSC. Can you tell me if this ordering is chronological, alphabetical, or numeric? Okay, let's take another example. Your grandfather keeps a telephone directory which contains his friends' names and their numbers. Which order is this directory most likely to follow? Merging is taking two sorted data structures and joining them in such a way that the final data structure is also sorted. This operation can only be conducted on two sorted data structures. The challenge is to keep the sorted order intact in the final data structure. Suppose that two teachers collect final exam papers from two different classrooms. Each teacher sorts his or her own pile of answer scripts. Then they bring their sorted piles to the class advisor. He will now merge the two sorted piles. Assume that teacher A's pile has scripts of roll numbers 1, 2, 6, 9 and 10. Assume teacher B's file has scripts of roll numbers 3, 4, 5, 7 and 8. So the class advisor goes about like this. He picks 1 and 2 from A's file. Then he picks 3, 4 and 5 from B's file. Then he picks 6 from A's file. Then he takes 7 and 8 from B's file. And finally, he adds 9 and 10 from A's file. And now the class advisor has a pile of scripts that is sorted too. Types of data structures. There are many common data structures including arrays, linked lists, stacks, queues, and trees, to name a few. And we have full chapters on each of these names. All data structures store a collection of values but differ in how they organize the individual data and by what operations can be applied to manage the collection. The choice of a particular data structure depends on the ADT and the problem at hand. Some data structures are better suited to certain problems. Now I have a few tasks for you. Task number 1 says, a mother compiles a baby book for her infant in which she notes his important achievements. What order is she most likely to follow for the content? Task number 2 says, you have 50 books. You can keep them in either a big bag or in a cupboard with 3 shelves or in your elder brother's carefully catalogued library. Where will insertion be the easiest? Where will searching be the easiest? Where will sorting be the easiest? Submit your response on a Google form in the assignment titled Lecture 1 Tasks in Google Classroom. So what did we learn today? We learned about the algorithm. We learned about abstraction and its types. We explored the abstract data type in detail. We were introduced to the idea of a data structure. We explored the operations performed on a data structure, and we were introduced to different kinds of data structures. Things to do. In the end, I will leave you with a few things that you have to complete before meeting me in the online session. Read the book. Submit your answers to the tasks in this lecture. Note your questions and put them up in the relevant online session. And email suggestions on content or quality of this lecture at urujn@neduit.edu.pk. I hope that we have a good semester. Take care. Allah.